So, friends, the next question that was asked, it was from hardcore geography. Very simple question. Discuss how changes in the shape and size of continents and ocean basins take place due to plate movement. मतलब how plate movement results in the changes in the shape and size of continents and ocean basins. So hope the basics are clear. कि basically plates are what? Plates are rigid lithospheric slabs. Plates are rigid lithospheric slabs which are floating over partially molten asthenosphere. These oceans and continents are located on these plates. जैसे ये plate है, a part of it may be oceanic crust, a part may be continental, then again oceanic. जो plates जो continents और oceans है ना, they are located on plates. Plates are made up of crust as well as uppermost mantle, and they are floating over partially molten but denser asthenosphere. And as the plates move under the influence of thermal convection current, it not only changes the shape but also the size of oceans and continents. How? That is what I am precisely going to discuss over here. There are 7 major plates, 9 minor plates, 6 सब plates. अब ये सारा कॉन्सेप्ट अब आंसर में तो डिस्कस नहीं कर सकते, ब्रीफली बता दो. प्लेट टेक्टोनिक्स is the study of deformation of plates and interaction of plates along their margins. Plates are rigid lithospheric slabs which are floating over partially molten asthenosphere, and these plates are the continents and oceans are located on these plates. Now question is how plate movement changes the shape and size of continents and oceans. See, these plates are continuously moving. As a result of their movement, at places they are moving away from each other, at places they are moving towards each other, at places they are sliding past each other. There are three types of plate boundaries. One, divergent plate boundaries. Divergent plate boundaries where the two plates are moving away from each other. Where the two plates are moving away from each other. Now divergent plate boundaries, and second is convergent plate boundaries. Where the plates are moving towards each other and the heavier plate gets subducted below the lighter plate. Convergent plate boundaries. And third is sliding plate boundaries, where the two plates slide past each other. Neither the plate is created nor it is destroyed. These are sliding plate boundaries, where the two plates slide past each other. है ना? They are sliding, moving in parallel and opposite direction. So let us see how plate movement brings about changes in the shape and size of continents and ocean basins. First, divergent plate boundaries. How do they get formed? See, divergent plate boundaries can get formed on ocean floor also and on continents also. Whenever, suppose this is a continental landmass, whenever rising thermal convection current, wherever rising thermal convection currents are found, the divergent plate boundaries come into existence. Divergent plate boundaries. In this process, you will see how the shape and size of oceans comes into existence and how do they change. Now, wherever the rising thermal convection currents are found, the divergent plate boundaries come into existence. And if this rising thermal convection current happens to occur below continental plate, continental part, this plate may be having oceanic crust also, but if the rising thermal convection current happens to take place before the continental part of the plate, continents are thick, then what happens? The rising thermal convection current, they bring magma along with them. And as this magma reaches the base of the crust, base of the plate, continental part of the plate, it not only melts the plate but also pushes the plate from below. The rising magma not only because continental part of the plate is having more silica, its melting point is high, it's not easy to get melted. Agar yahin par basically there would have been oceanic part of the plate. If oceanic part of the plate would have been here, then this oceanic crust would have got easily melted. Not only it is thin, but it is having less silica, more iron and magnesium. So the melting point of basaltic oceanic crust is less, but the continental part of the plate is having more silica. So it is having higher melting point. So the rising thermal convection current will initially melt the plate, and this also pushes the plate from below. As a result of this, a dome shape gets formed on the surface. Because of this push, a dome shape comes into existence on the surface. Since it is a rigid body, since crust is a rigid body, and when magma pushes from below and dome shape gets formed, cracks appear. Cracks appear on the crust. Cracks appear on the crust. As a result of these cracks, it gets cracked, and as these thermal convection current diverge, they stretch the crust from below. They stretch the crust from below. As a result, what happens? These cracked portion collapse. These cracked portion collapse, and as a result, a rift valley gets formed on the land area. A rift valley gets formed. This is the first stage of plate divergence, and this is known as intracontinental rifting. Intracontinental rifting. This is the first stage of plate divergence. When a rift valley comes into existence, it is long, narrow, and deep. For example, you can see the example here. Example of rift valley getting formed by this process is East African Rift Valley. You can see East African Rift Valley. See this East African Rift Valley runs like this. This Lake Rudolph, Lake Edward, Lake Albert, Lake Edward, Lake Tanganyika, Lake Malawi, all are located on within East African Rift Valley. This is the first stage, formation of Rift Valley. Long, narrow, deep valley. It is long, narrow, deep valley. It is the result of plate divergence. It represents first stage. Sea water has not entered into it. It still have freshwater lakes. Rudolph, Turkana कहते हैं उसको, Albert, Edward, Kivu, Tanganyika, Malawi, all these freshwater lakes are there. East African Rift Valley is the example of first stage. छोटा हो जाओ भाई. Now, first stage over. Now second stage. Second stage is called interplate thinning. In second stage, this regular melting continues. Second stage is interplate thinning. Interplate thinning. Here the regular melting of the rift valley, base of the rift valley, creates numerous cracks in this base of the rift valley, cracks. And because of regular melting, यहाँ से कुछ basaltic magma also reaches the base of the rift valley, basaltic magma. And because of regular melting, this crust becomes very thin. As a result, the floor of the rift valley subsides. It sinks down. Because of regular melting from below, कुछ तो क्रैक्स बन जाते हैं जिसके थ्रू ये बेसाल्टिक मैग्मा एंटर्स द फ्लोर ऑफ द रिफ्ट वैली. And secondly, because of thinning of this rift valley, it sinks down. It sinks down to an extent that seawater from the surrounding region moves in. Seawater gets filled in the rift valley. This is the second stage. See, second stage. See, second stage. This Red Sea represents second stage. Red Sea represents second stage. Red Sea is also located in a rift valley, but it is in second stage where the sea water has entered into the rift valley. East African rift valley is in first stage. Sea water has not entered. रेड सी के बेस में जाके देखोगे ना, उसकी तली को जब तुम साफ छुओगे, यू विल फाइंड सम बेसाल्टिक रॉक्स आल्सो व्हिच हैव crept inside through the narrow cracks. And because of thinning of the base of the rift valley, it subsides, so the sea water enters into the rift valley. Red Sea represents the second stage of divergent plate boundary. Now third stage is ocean ridge formation. Now what happens once sea water has entered into it? Now this regular melting continues. As a result, the continental crust ruptures. As a result of this rupture, it ruptures from below, अलग हो जाते हैं. And these two pieces start moving, these two crustal pieces start moving away under the influence of this rising thermal convection current. They start moving away. As a result of this movement, they start moving away. And the magma coming from below starts getting attached to the trailing edges of the two crustal pieces. The magma coming from below starts getting attached to the trailing edges of these two continental masses. As a result, new oceanic crust gets formed. पहले दोनों पास थे. Now because they have got ruptured from below, third stage, ocean ridge formation, it has got ruptured. Magma coming from below starts getting attached to the trailing edges of these two land masses, and this leads to the formation of new basaltic oceanic crust, and some magma gets deposited on the trailing edges in the form of oceanic ridges. And the sea that was in the form of narrow Red Sea, it gets expands. For example, third stage, see here, initially India was attached to Africa. ये जो जगह है ना, India was attached over here. Gradually ईस्ट अफ्रीकन रिफ्ट वैली की तरह रिफ्ट वैली बनी, फिर रेड सी की तरह सी एग्जिस्टेंस में आया. एज ऑफ नाउ you can see this Carlsberg ridge in between. Carlsberg ridge, this is Arabian Sea, this is Somali Sea, and this is India, Peninsula India, and this is Africa. This is the third stage when oceanic ridge and oceans come into existence. This sea on this side, and this continues. An Atlantic Ocean like Atlantic Ocean, mid-Atlantic ridge, isn't it? Eurasia, North America, Africa, South America, such extensive Atlantic Ocean comes into existence. See, the shape and size of ocean is changing. Initially it was land. First stage, intracontinental rifting, Rift Valley came into existence. That was purely land area. Second stage, the Rift Valley got subsided and ocean water entered into it, and Red Sea like feature got formed. It represents second stage. And third stage, it continued to move away, and ocean ridge formation, a ridge got formed because this magma coming from below initially Initially तो ये it was very close. Initially it was like this. This was like this Rift Valley. Third stage में the two land it gets ruptured. The base of the Rift Valley gets ruptured, and these two land masses नीचे से जो मैग्मा आ रहा है ना, it continues to get attached with the trailing edges and continues to drag these two land masses away, and the magma continues to get attached to the trailing edges. ये water body बन गई थी, and as a result, as it moves away, more and more oceanic crust gets attached, and this continues to happen, and ultimately this will move away and extensive oceanic crust will come into existence. This is how Atlantic Ocean got formed. Pangea tha, it was landmass, and this is how it got ruptured, and these two pieces drifted away, and Atlantic Ocean came into existence. Now, how continental areas also get modified. Now see, when two plates converge, this convergence takes place in 3 steps. First, oceanic convergence. When the place where the convergence is taking place, if on either side only oceanic crust is present, it is known as oceanic convergence. This plate is both continental and oceanic. This is also continental and oceanic, but the place where convergence is taking place, on either side only water body is there, so it is oceanic convergence. And once this oceanic crust completely converge, this continental landmass will come over here. Continents cannot subduct because it is oceanic crust which is heavier, which always subducts. Now this oceanic crust starts subducting below this plate. This in this case, on one side continental landmass is there, on the other side oceanic crust is there. This is known as oceanic continental convergence. And when this continues and these two plates come sufficiently close, sediment derived from these land masses that is being deposited in the sea, it continues to get deposited, and when they come sufficiently close, this sediment starts getting squeezed and folded into fold mountain. And when this fold mountain gets formed, both plates join together and become one and start moving together in one direction. For example, this is Eurasian plate in north, and Indian plate was subducting below Eurasian plate. Still it is subducting. Tethys Sea was lying over here. This is Eurasian plate. This is Indian plate. Now from Eurasian part, sediment was getting deposited here. From Peninsular Plateau, sediment was getting deposited here. As it continued to subduct, this continental part continued to come closer and closer, and when it came sufficiently close, the sediment deposited in the sea started getting squeezed and folded. As a result, a succession of mountain ranges emerged: Great Himalayas, Middle Himalayas, Shivalik. And when they become very close, the subducting part stop subduction बंद हो जाता है when they are almost jointed along the suture zone. These two plates get well jointed in the Sangpo suture zone, है ना, they get well jointed, and this subducting part stops subduction. It falls into the mantle, and the two plates become one and start moving in one direction. अभी कुछ लाख साल बाकी हैं, and Indo-Australian plate and Eurasian plate will become one, and they will start moving in one direction. So the shape of the continental landmass has also changed. Initially it was water body over here. Now there is no water body in place of Tethys. Himalayas have come to occupy their position. So this is how the shape and size of oceans and continents keeps on changing because of plate movement. Continents and oceans both are located on plates, and this plate movement, therefore we say plates are amorphous, shapeless. They are continuously being formed and deformed. Now next question was, discuss the distribution and density of population in Ganga river basin. Distribution and density of population in Ganga river basin, and with special reference to land, soil and water resource. How land, soil and water resource has influenced the distribution and density of population in Ganga river basin. When you talk about Ganga river basin or Ganga catchment area or Ganga drainage basin, this means Ganga drainage basin basically extends to the south of Himalayas, to the north of Vindhyas and to the east of Aravalis. मतलब जहां से पानी गंगा में आ रहा है, that is Ganga basin. Rivers, the left bank tributaries coming from Himalayas. Then you can see its right bank tributary including Yamuna, and this Banas river coming from Aravali, Chambal, Sindh, Betwa, Kane, Son and Rihind, all coming from right bank. And then Yadav Ram Ganga, you can see this Ram Ganga, this is Gomti, this is Ghagra, Gandak, Koshi, Mahananda coming from left bank. This entire region from where the water drains into Ganga river, that is the Ganga river basin or catchment area of Ganga. It is huge. This Ganga river basin lies north of Vindhyas, south of Himalayas and east of Aravalis, from where Banas river drains into Chambal, Chambal drains into Yamuna, Yamuna drains into Ganga. This is 24% of the total geographical area of the country, and it holds 43% of the total population of the country. Ganga basin is one of the largest basin in the world. It is one of the largest basin in the world. Now we have to discuss the distribution of population and the distribution and density of population in Ganga basin with special reference to soil, land and water resource, because it is the soil, land and water resource that has influenced the distribution and density of population in Ganga basin. If you see, this basin is spread over 10 states: Himachal Pradesh, Uttarakhand, UP, Bihar, Jharkhand, West Bengal, Chhattisgarh, MP, Rajasthan, Haryana. These are the 10 states where the Ganga basin is spread. If you see in the northern part, in Himachal Pradesh and Uttarakhand, if you see, the terrain is hilly and rugged terrain. As a result, density of population is low in the northern part of Ganga basin. The Ganga basin in the northern part, population density is low because of hilly and rugged terrain. Here in Himachal Pradesh and Uttarakhand, the cultivable land is limited, but it is known for its orchards. Here Ganga, Yamuna and Ram Ganga have their source region in Uttarakhand. Now in the western part of this Ganga basin, drained by Banas river, Chambal, Sindh, Betwa, Kane and Son, in the southern part, here you find that the density of population is low to moderate. In western part, it is draining the eastern part of Rajasthan, and northern part of Malwa plateau is being drained by this Chambal, Sindh, Betwa, Kane and Son. They drain the northern part of Malwa plateau. In this region, the population density is low to moderate due to low and erratic rainfall and limited irrigation facilities. The density of population is low to moderate. Although no doubt the black soil of Malwa is intensely cultivated, But here you find Bundelkhand Plateau, Baghelkhand Plateau, where the soil is rocky, where agriculture in the western part of eastern part of Rajasthan, soil is sandy. Here agriculture irrigation facilities are highly limited. Underlying terrain is rocky, so well irrigation or tube well irrigation is not possible. Canals are absent, so limited irrigation. So agriculture is also not very intensive. So population is low to moderate. And Chambal and its tributary have carved out deep ravines in these regions. सबसे important part है ये middle part. This middle part comprise of UP. Here in the middle part UP कहना रहता है. It comprises of Ganga Yamuna Doab, Rohilkhand Plain and Awadh Plain. Ganga Yamuna Doab is area between Ganga and Yamuna. Then area drained by Ram Ganga is Rohilkhand Plain, and area drained by Gomti is Awadh Plain. Here height gradually decreases, but this part of this Ganga Plain is highly very fertile. A dense network of canals, intensive tube irrigated area, soil is fertile. Green revolution has made its great impact. Here agriculture is very intensive, and basically density of population is high. So here in Ganga Yamuna Doab, Rohilkhand Plain, Awadh Plain, soil is fertile, extensive canal and tube well irrigation, population density is high in both rural and urban area. In eastern part, Bihar, it comprises of Ganga Ghagra Doab, Ghagra Gandak Doab, Gandak Koshi Doab, that is Mithila Plain. South of Ganga, it is Magad Plain, and Mahananda forms Barin Plain. So Bihar is basically made up of Ghagra Gandak Doab, Gandak Koshi Doab, that is Mithila Plain, Barin Plain formed by Mahananda, and south of Ganga, that is Magad Plain. Here you find trend of rainfall increases. As you move eastward, the elevation decreases and the trend of rainfall increases. As a result, Magad Plain, Barin Plain, Ganga Gandak Plain, Mithila Plain, here land is fertile, abundant water, population density is very high, agriculture is very intensive. Here silty clay soil is found, so paddy cultivation increases, intensive. And in the lower catchment area of Ganga, here we have West Bengal, where the Ganga divides into distributaries. Slope of the land is very gentle, soil is pure clay, and here very intensive rice cultivation is done. Every bit of land is put to cultivation. In fact, in paddy fields also pissi cultivation is done. Population density tend to be very high in lower Ganga plain. Here basically 2 to 3 crops of paddy are raised along with jute cultivation in the Hooghly Valley. Land is fertile, which makes up for the high density of population. The carrying capacity is very high. Here in near the mouth of the Ganga, dense mangrove forests are found, which are the habitat of basically Royal Bengal tigers. Here cultivation is confined near up to the mouth. Because of extension of cultivation, mangroves have suffered a lot from human activities. So this was about this question.